All right, we're going to be running through Bellman-Ford's algorithm on this graph right here. It's used to find the shortest path from a single node or from a single source vertex to all the other vertices in a weighted graph. So we have a weighted graph right here. I just drew it out for visualization purposes, and our adjacency matrix is right here. So we can just go ahead and get started. So on our left side, we have our passes, and on our top row, we have our node count. So our first pass is going to count as our initialization layer. So in this specific problem, our starting node is going to be 5. Okay? So we mark 5 with the cost of 0, since this is our starting node, and it's basically free to get there. And then we're going to mark the rest of them as infinity, because we haven't reached any of these nodes yet. Okay, so now once we finish the first pass, which acts as our initialization layer, we're actually going to process node 5. So we're going to come down here to the graph, and we're going to see what nodes does 5 connect to. So it connects to 1, 2, and 4 with these specific costs. So we're going to refer to this table here. We're going to see from 5 to 1, is there a cost that's cheaper than 1? There is not. So we can update it here. Okay? We're going to do the same thing for node 2. So from 5 to 2, is there something in the table that is cheaper than 1? There isn't. So we're going to update it since this is infinity. We're basically comparing these two. Okay? And if the new value is less, then we just update it. Okay? And next node we have to process is 4. So from 5 to 4, it's 2. And right now the cost to get to 4 is infinity, so we're just going to update that. Okay, now this row is done. We can just bring down the other values. Okay, and the next nodes we want to process are going to be the ones that we just updated. So these two and this one. So we're just going to start in order. So let's just go from this one first. So from node 1. All right, let's focus on this row now. Okay. So from node 1, 1 to 0 is 1. Okay, so we found a cheaper edge. So what we're going to do is we're going to take this value and add it to the cost to get to 0, because you're coming from 5, then you're going to 1, and then you're going to 0. So you're adding the costs, you're adding the edge costs. So the cost to get to 0 from 5 is how you read it, and then it would be 2. So you're adding the 1 from here and the 1 from here. The 1 from here is the cost to get to 1 from 5, and then the 1 from here is the cost to get to 1 from 0. So you add those two and it becomes 2. All right, you can process the next node now, which is 2, with an edge weight of 5. So to get to 1 to 2 is 5. So let's see if that's cheaper than what we have. So we add 5 plus 1, which is 6, which is not cheaper than 1. Okay, so we can just skip that value. And now we have node 3 with an edge weight of 2. We're going to see, is 2 plus 1 greater than infinity? Or is 2 plus 1 less than infinity? It is. So we can update that here. And again, we're just taking this value and adding it to this. So 2 plus 1 is 3. Because the total cost to get to node 3 from 5 is 3. Okay? So I'll visualize that in the graph right here. So to get to 3 from 5, you go to 1, you take this path, and then you take this path right here. And then you just add the edge weights. So 1 plus 2 is 3. All right. Now, let's see. Okay, the last node is 5. Cost to get to 1 to 5 is 1. 1 plus 1 is 2, which is not which is not less than 0. So we can just keep that. All right, now this node is completely processed. We can move on to 2. Okay, so now we're going to be focusing on this row. All right, so the cost to get to node 1 from node 2 is 5. So we add 5 plus 1, which is greater than 1, so we do not need to update this. All right, we can go to this next node here. So 2 to 5, the cost is 1. 1 plus 1 is 2, so we do not need to update it. All right, now we finished this node completely because we processed these two already, so we can move on to right here. And as I was saying, we're choosing these nodes to update because they were just updated from the top row. Okay, so now we're here. Now node 4, let's look at here. So the cost to get to node 3 from 4 is 1. So what we're going to do is add 1 to the value of 4, which is 3, and we're going to see, is that less than or equal to what we have for the current value of 3? It's less, so we're just gonna, or it's equal, so we're just gonna keep it the same. Okay, and then processing 5, we can skip this 5 part because we already know this is our starting node, so we can just cross this out completely, and now we have a smaller graph to work with because this is the cheapest edge we're gonna get, 0, because it's the starting node, so it was basically free to get there, and nothing's gonna be cheaper than that. All right, so now that this row is processed, we're just gonna bring down the old values. All right, so what's new from this top row that just propagated into the bottom row? It's node 0 and node 3. Okay, so we're gonna focus on these two to create the next row. Okay, and how you stop this algorithm is when you get 2 repeated rows. So once you get a repeated row, that's when you know to stop. All right, so let's start with node 0 right here. Okay, so the cost to get to 0 to 1 is 1, so we're going to add 1 to 0, which is 3, which is greater than what we have at 1, so we're just going to keep that the same. All right, so we can process 3 next. So the cost to get to 0 to 3 is 10. We're going to add 10 to our current value of 0, which is 12, and we're going to see, is that less than the current value we have at 3? It's not. Okay, now this node is completely processed. We can move on to 3 because this is our next node that we need to process. Let's go down here. We're going to see, so the cost to get to 3 to 0 is 10. We're going to add 10 to 3 and check if that's less than what we have at 0 currently. It's not, so we can just ignore that value. We can move on. The cost to get to 3 to 1 is 2. So we're going to add 2 to the current value of 3 and check, is that less than what we have at 1? It's not, because 3 plus 2 is 5, and that is not less than 1. All right, so we can move on to the next value. So the cost to get to 3 to 4 is 1. We're going to add the value of 3 to 1, so 4, and then check, is that less than what we have at 4? It's not, because 4 is greater than 2. So what's going to happen in this row? We're just going to bring down our old values. And now if you notice something, we have 2 repeated rows here, so we know to stop the algorithm. And this is our final answer here. Yep, that's it.